Hello, Algebra 2 students. This is a Regent review on Unit 7, Complex Numbers. Each section of this video will be a different standard that the Regent could ask you questions on. So first, you just have a quadratic. And when you see your options have I in it, you know it's probably going to be a complex solution or an imaginary solution. So you're not going to be able to factor this. So what I'm going to do, you set it equal to 0. Whoops, 13 minus 9. And now you just use quadratic formula. List out your A, your B, and your C. The quadratic formula is provided on the Regent reference sheet. So negative, negative 2. Make sure you put, when you're substituting in, you use parentheses so that, let's say it is negative, you don't make that mistake of accidentally not squaring part of the value you're plugging in.
Sorry, I don't have an answer for that.
Just, ignore her. 2 squared minus 4 times 5 times 4 is negative 76. So, when we have a negative, we could pull out that radical negative 1 and make it I. So that would be the same as saying but that doesn't match any of our answers, so we're probably going to have to simplify the radical. So what I'm going to do in my calculator, I'm going to go to y equals, type in 76 divided by x, and then go to my table of values. And I want to see all the factors all the factors are the ones that are whole numbers. Okay, so those are all your factors of 76. Which one contains a perfect square? Look at that, it's 4. So this is the same as saying 2 plus or minus I radical 4 radical 19 over 10. What's the square root of 4? 2. So now 2 divided by 10 is 1/5. 2I radical 19 divided by 10 would just be I radical 19 over 5. So your answer would be 2. We're basically going to do the same thing here. It already equals 0, so just list out your A, your B, and your C. Plug into the quadratic formula. Simplify what you can. 5 squared minus 4 times 2 times 8, negative 39. I'm checking the factors of 39. 1 and 39, 3 and 13, and that's it. So no perfect squares. So the last step, just pull out your I. Right? Square root of negative 1 is I. it wants it in a plus bi form. So let's put it in that form. X equals negative 5 over 4 plus or minus radical 39 over 4 I. And now it's in a plus bi form, right? A is your real component. Bi is your imaginary component. For number 3, algebraically determine the roots in simplest form, a plus bi form, to the equation below. Consider the system of equations below. The graph of this system confirms the solution from part A is imaginary. Explain why. So, first, let's solve. You want it to equal 0 before you use quadratic formula. So you're going to subtract 4x and add 10 to both sides. List out your A, your B, and your C. A is 1, B is negative 6, C is 17. Plug that into the quadratic formula. Negative 6 is positive 6. 6 squared minus 4 times 1 times 17 is negative 32. It wants simplest a plus bi form. So we could pull out the I. 32. I believe the greatest factor that's the perfect square is 16. Let's just check that. 32 divided by x. I see is 1 and 32, 2 and 16. So 6 plus or minus radical 16, radical negative 1, radical 16 times 2 is 32. So we have 6 plus or minus 4i radical 2 over 2. And then lastly we simplify that. 6 divided by 2 is 3. 4 divided by 2 is 2. And it wants it in a plus bi form, so 2 radical 2i. That's your answer. Those are your two solutions. Now, it wants you to graph those two equations, right? It wants you to graph this function and this function. So I'm going to put that in my calculator. X squared minus 2x plus 7, 4x minus 10. And when I graph it, it looks like this. When I graph it, it looks like this. Will these ever intersect? No, right? And this confirms the solution from part A because the only time they would intersect is an imaginary solution. There's no real intersection points there's no real points that intersect. There are only complex solutions. Okay. Does the equation have imaginary solutions? Now this, you could do two things, right? you could use your quadratic formula or you could use the discriminant, which is part of your quadratic formula, right? When do you have an imaginary solution? It's when you have a negative in your radical, right? So if this equals a negative, then it's going to be imaginary. That part that I highlighted is called your discriminant. So if your discriminant is less than 0, that means you have two complex solutions. If it equals 0, then you would only have one real solution. And then if it was greater than 0, then you would have two real solutions. Do you have to know this? No, you could just use the quadratic formula. You know what? I want to keep that. You could just use the quadratic formula and prove that you have two imaginary or real solutions or one real solution because of the answer that you receive from the quadratic formula. But let's use the discriminant law because we just did that a lot. List out your A, your B, and your C. 1, -4, 13, and just plug into the discriminant. So we have -4 squared minus 4 times 1 times 13. You get -36. So -36 is less than 0, which implies two complex solutions. Okay. Which representation of a quadratic has imaginary roots? These are two real roots. This is one real root. For these are not trinomial, so you don't have to factor or use quadratic formula. You could actually just solve. So divide by 2. Take the square root of both sides. Because you're taking the square root of an unknown, you must include the plus or minus sign. Subtract 3. And look at that. You have 1, 2 real roots. It's going to be an irrational number, right? So it's going to be a long decimal, but it still exists. So that's two real roots. Remember, in order for it to be imaginary, it has to have a negative in the radical, a negative radicand. So that leaves number 4, but let's just check to see that we didn't make a mistake. You subtract 32. You could already see where that negative comes from. Divide by 2. Okay, and then take the square root of both sides. Remember to include plus or minus. So you have x equals plus or minus 4i. Square root of -16 would be 4i. Those are two imaginary solutions. So your answer would be 4. Which equation has roots of 3 plus I and 3 minus I? So, first, let's weed out some answers. What you could do, go to y equals and input every one of these equations. Graph them. And when you graph it, if it crosses the x-axis, if there are zeros, that means that it has two real roots or one real root. And that is not imaginary, so you can immediately cross out that option. So the first one does not cross. The second one does. The third one does. Did the fourth one cross as well? Yeah. The fourth one crossed as well. Typically, when they give questions like this, I know I gave questions like this throughout the year, I just changed all the signs. I don't switch the 6 and the 10. So then you would likely have two equations where you have imaginary solutions. And then when they're just switching the signs, the only difference would be you could have these solutions or you could have a negative in front. And obviously you would choose the one that's positive because the question is asking for the positive one. But let's just check that our answer is right. A, B, C. And the way to check that is to do what we're doing here. So 1, negative 6, 10. Plug it in to quadratic formula. Positive 6. Six squared minus 4 times 10 is negative 4, which is just 2i. So 6 plus or minus 2i over 2, which equals 3 plus or minus I. That is 3 plus I and 3 minus I. The answer was 1. Okay. Oh, look at that. This is what I was talking about. Where we kept the numbers the same, but they just switch every sign. They give you every possible combination of signs. So, that means we're going to have, when we graph all of these, we could cross out all the ones that cross the x-axis, right? And the ones we want to look at are the ones that don't touch the x-axis. Okay. So, let me do that. I'm going to go to y equals. Okay. Delete all the ones that I put in before. Alright, and I'm putting these ones in now. X squared plus 2x minus 2. X squared plus 2x plus 2. X squared minus 2x minus 2. X squared minus 2x plus 2. I'm going to graph, and I'm going to keep a careful eye, the order that they're graphing, right? And which ones are, if it crosses the x-axis, I know to cross it out. First one crosses, so cross it out. Second one doesn't. Third one does. Fourth one doesn't. So, we have two options now. We're going to have to put this into our quadratic formula. X equals so option 2, option 4. One, 2, 2. 1, negative 2, 2. Okay. And we know if we want the first term to be positive, that it's clearly going to be the negative negative. But just for kicks, let's do it. 2 squared get -4. You would get -2 plus or minus 2i over 2. +2 plus or minus 2i over 2. And lastly, we want the one that's positive, so that's option 4. Option 4 would be your answer. Okay. For a question like this, it looks really difficult, but it's actually really easy. All you're doing is plugging in A, B, and C, right? So A minus B times C equals, what does A equal? -3 plus 5i minus, what does B equal? 4 minus 2i. What does C equal? 1 plus 6i, right? Now, what you could very easily do, you go to mode, make sure you're in A plus BI mode, right? You could just put this in your calculator. I'm going to just input it exactly as I wrote it in my calculator. To get I, you do second decimal. Okay? And my calculator gave me the answer. Equals -19 minus 17i. Okay? But, for sakes of reviewing, let's go over how you would do it without a calculator. So nothing's happening on the outside of this parenthesis, so you could drop them. There is something happening with the subtraction there, so you can't just drop it. But first, let's multiply. You treat I like it's a variable until the last step. So, minus 4 times 1 is 4. 4 times 6i is 24i. -2i times 1 is -2i. -2i times 6i is -12i squared. The reason I had to put parentheses is because this negative, right, we're going to have to distribute out that negative. But first, let's simplify. 24i minus 2i is 22i. Distribute out the negative. Okay. Combine like terms. -3 minus 4 is -7. 5i minus 22i would be minus 17i. And then plus 12i squared. So we simplified it as best we could. Now, we know that I equals radical -1, right? What about I squared, though? If you square a radical, it cancels out, so you would get -1. If you, let's say we had I to the third, you would do -1 times I, so that's just -I. And then I to the fourth is just I squared times I squared, so -1 times -1, +1. If I did I to the fifth, it would go back to I, because you're multiplying by I. Again, if I said I to the sixth, that would be -1. It's a cycle of 4. So 12i squared is just I squared would be -1. So we have -7 minus 17i plus 12 times -1 which is just negative 7 minus 17i minus 12. Negative 7 minus 12 is negative 19 minus 17i. And that's exactly what we got. Obviously, it was much easier to put that in your calculator. Just make sure you're in A plus BI mode. Which expression is equivalent to this? Now, unfortunately, we're not going to be able to use our calculator for this one because there's an abstract term. So this one you would actually have to distribute out. But let's say you didn't want to distribute out, right? Something that you could do, you could just choose a random value for x. I would use like 3, 7 maybe. And then plug in, and then plug into your solutions for x, and then see which one that would equal, right? But let's do it. We have 2x minus I times 2x minus I, right? Because there's a square, minus 2x minus I times 2x plus 3i. So we're going to have to distribute 2x times 2x, 4x squared, 2x times negative I, negative 2ix, negative I times 2x, negative 2ix, negative I times negative I, positive I squared. Minus, we'll do the same thing here. 2x times 2x, 2x times 3, I, negative I times 2x, negative I times 3i. Okay? And make sure you include the parentheses because we didn't distribute out the negative. Combine like terms and then distribute out the negative. So we have 4x squared minus 4ix plus I squared minus 4x squared 6ix minus 2ix would be 4ix. So positive 4x times negative 1 would be negative 4ix. And the reason I color coordinated it, so that's why I was switching between blue and black, because I'm showing that I distributed that negative. Okay? Remember, I squared is just negative 1. Oh, and we could also combine like terms. So before we do that, let's combine like terms. 4x squared minus 4x squared cancels out. 4ix, negative 4ix minus 4ix would be negative 8 4ix. Negative 8ix. I squared plus 3i squared would be 4i squared. Remember, I squared is just negative 1. So we have negative 4 minus 8xi. So that's your answer. Again, you could have just chosen a value for x, a random value, and just plugged in. Elizabeth tried to find the product of 2 plus 4i and 3 minus I. Identify the error in the process shown and determine the correct product. So first, let's see what Elizabeth did wrong. She multiplied 2 by 3 and got 6. 2 times negative I and got negative 2i. 4i times 3 is 12i. 4i times negative 1, negative 4i squared. That's correct. Now she combined like terms. Negative 2i plus 12i is 10i. That's correct. Now she changed I squared to, what is I squared equal to? I equals radical negative 1. I squared is just radical negative 1 squared, right? Which is just negative 1. Did she plug in negative 1? No. So the error is I squared equals negative 1, but Elizabeth plugged in positive 1 for I squared. Okay, so let's just start from there now. 6 plus 10i minus 4 times negative 1, not 1. So 6 plus 10i plus 4, 6 plus 4 is 10. 10 plus 10i. Really easy thing you could have done in your calculator. If you're in A plus BI mode, you would put 2 plus 4i times 3 minus I, and in my calculator it says 10 plus 10i. We were right. So you could even check your work. Okay. Lastly, we have this question here. First, this looks complicated to me, right? So, it's all numbers, so I could just put that in my calculator if I'm in A plus BI mode. So negative 1/2 times I to the third times the square root of negative 9 minus 4 minus 3 I squared. My calculator tells me that what we're going to get is 1.5 minus 2i, which is just 3 over 2 minus 2i. Right? We have the answer, but notice this isn't a multiple choice question, so you do have to show your work. So let's try to solve this. We know the square root of negative 9 is 3i, right? So we have negative 1/2 I to the third times 3i minus 4 minus 3i squared. Distribute out. So negative 1/2 I to the third. So negative 1/2 times 3 is negative 3/2. I to the third times I is I to the fourth. Plus, because negative times negative is plus, 1/2 times 4 is 2. I to the third minus 3i squared. Okay. We're basically done. We have this simplified. We just have to replace I to the fourth, I to the third, and I to the second. So, I to the first power is radical negative 1, right? Or we could leave it as I to the second power is radical negative 1 squared, so it's just negative 1. I to the third, you'd be doing negative 1 times I. So that is negative I. I to the fourth would be essentially saying negative I squared, which I squared is negative 1, so negative negative 1 is positive 1. So let's make those replacements. Negative 3/2 I to the fourth is positive 1. I to the third is negative I. And I to the second is negative 1. So we get negative 3/2 minus 2i plus 3. So then lastly, we're doing negative 3/2 plus 3. You can put that in your calculator. Negative 3/2 plus 3. Convert to fraction, you get 3/2. So 3/2 minus 2i. Underline that like terms. So that's your answer. Isn't that what your calculator got? Okay. Hopefully this helped. Thank you.